After completing the Ethernet built-in tutorial in the previous video, we'll start with a simple exercise to go through the entire process. First, we should set the defaults correctly. Go to Projects/Defaults, then to the Hydraulics tab, and set the flow unit to liters per second LPS. For the head loss formula, select Hazen-Williams, HW, and if desired, save these settings as the default for all new projects. In the Properties tab, set the pipe roughness to 140, which corresponds to plastic pipes when using the Hazen-Williams equation. Once this is set, we can start drawing the network. When the layout is complete, we'll add the demand. Each node has 4 taps, with each tap requiring 0.2 liters per second, resulting in 0.8 liters per second per node. Note that while the sphere standards specify a minimum of 0.125 liters per second, this would require 9 hours of distribution to supply the minimum prescribed amount of water, which is unlikely in most camps where distribution lasts 5 hours at most. 0.2 liters per second is better suited to site realities and avoids issues. Instead of assigning demand node by node, we'll use Edit Group to apply the base demand to all taps at once. To do this, go to Edit/Select All, then Edit/Group Edit. Notice how here you need to make a sentence describing what you want to do. For all junctions, within the outlined area, replace base demand with 0.8. Confirm the changes. The pipe material is HDPE-PN10. With this information, we can look up the internal diameters in a chart provided in the base manual. We are going to give the entire network a tentative diameter to start with, 110 millimeters, which has an internal diameter of 97 millimeters. We use Group Edit again. Now we enter the remaining data for the nodes. To ensure all necessary numeric values are displayed on the screen, right-click anywhere on the screen, choose Options, Notation, and enable Display Node Values and Display Link Values. To assist with data entry, the map browser can be used to display node elevations and pipe lengths. After that, we enter the pipe lengths. If the display is difficult to read, we can adjust the legend colors or change the background to black in Map Options. To change the color, right-click on the legend, click on the color you wish to change, select another, and accept. To change the background, right-click the screen, select Options, and go to the Background tab. At any time, you can use the drag tool to refresh the screen. We can now run the simulation. We get a negative pressure error. This doesn't necessarily mean an input error, but rather that there are nodes that aren't receiving enough pressure. You can see nodes with negative pressures. The next step is to identify pipes that are too small to carry the required flow. In the map browser, selecting pressure under nodes and head loss unit under links allows us to visualize where the issues are. We adjust the legend intervals to improve clarity. Right-click on the legend and type the new values desired. Starting at 0 highlights all negative pressures in dark blue. Then, 10 in cyan lets us quickly see nodes that have pressure but are below the target of 10 meters. We do the same for unit head losses. Pipes with losses under 1 meter per kilometer are likely oversized, while those over 7 meters per kilometer are likely undersized. From the results, it's clear that the first pipe is too small, causing low pressures. Increasing its diameter to 140 millimeters, internal diameter 123 millimeters, improves the situation. But one node still has a pressure of 8.25 meters. Increasing the diameter of the second pipe should help. This iterative process continues until the cheapest functional system is achieved. In practice, work progresses from the reservoir downward, since changes upstream affect downstream conditions. Remember to run the simulation to update it with the latest changes. With these adjustments, the system now meets the required pressures, but there's room to optimize further and reduce costs. Some pipes have very small head losses, meaning they might be oversized. Since the minimum diameter we can use is 63 millimeters, there might be room to reduce their diameter. For example, one can be reduced to 90 millimeters, then to 75 millimeters, and so on. In this case, pressure is still above 10 meters at this node, so reducing the diameter of pipe 8 might be an option. We can also try to close some pipes to see if they are redundant and can be eliminated. In our case, closing the pipes drops the pressure below 10 meters, meaning these pipes can't be eliminated. After testing different configurations, the final design is established. Congratulations! You've now completed your first simple network.